Okay, so since you girls asked about basically all of the bookwork, let's start with number 18. Abby, what's your question with 18? Okay, so what do we have to know to tell if a segment is tangent to a circle? Okay, it has to be a right angle. So we're trying to find out if AB is tangent. So if, well, let me change colors. If AB, this line here, is tangent to this circle. So is this a right angle? So how do we do that? Yeah, Natalie, Pythagorean theorem. So if that's your right angle, then what's your hypotenuse? All right, so if your hypotenuse is 5, then you have to have Pythagorean theorem is a squared plus b squared equals c squared, right? So does 3 squared plus 4 squared equal 5 squared? So is AB tangent to circle C? Yeah, Thatcher, that's right, it is. Does that make sense, Abby? Okay, so whatever segment you're looking at on these 18, 19, and 20, you're looking to see if segment AB is tangent. That means it has to meet the circle at a 90-degree angle. So you have 3 separate triangles, right? On each problem, you have 1 triangle. You have to do your a squared plus b squared equals c squared, and then see, does it really equal? So for number 18, we said C was your 5, right? It was CB. So if we said 3 squared plus 4 squared equals 5 squared, is this true? 3 squared is 9, plus 4 squared is 16, and 5 squared is 25. So does 9 plus 16 equal 25? Okay, so that's what you're going to do for 19 and 20. You're going to figure out which side is C, which side is your hypotenuse, which is going to be the side that's across from angle B, and then set it up just like that. Does that make sense? Okay. So now let's look at 21. So 21, 22, 23 are all going to be similar. For 21, when we look at that, Natalie, what's your question? Did you get 10 by looking in the back of the book? So tell me what you did. Yeah, Abby. Okay, so 576 plus r squared, and then what's on the other side of the equal sign? Yeah, that's right, Natalie. So Abby, on these, again, we're using Pythagorean theorem. So same thing we did on 18, 19, and 20, except this time we kind of have numbers in there. I mean, sorry, letters in there, okay? So if we're looking at 21, Abby, remember the hypotenuse is the one that's across from the right angle. So our hypotenuse on 21 is r plus 16, right? Okay, so if it's r plus 16 and we're doing a squared plus b squared equals c squared, then we know that that is r plus 16 squared, right? Okay, so now what's our a squared and our b squared part? A squared can be r, right? It can be this side here. So it would be r squared. And then your b can be this 24. So r squared plus, ooh, I don't know why it did that. R squared plus 24 squared. Does that make sense? No, now we have to actually solve for r. Because look, the problem wants you to find the value of the variable. So now you have to actually work those out. So r squared just stays r squared, okay? And then 24 squared becomes what? Okay, 576. Now it's this part that gets very mathy, as we said in class. So what r plus 16 squared like that, it really means this, okay? R plus 16 times r plus 16. So that we have to FOIL out. Do you remember foiling like we did yesterday? Okay, so FOIL is you're going to multiply your first numbers together. And then next in FOIL is the O, so now you're going to multiply your outside numbers together. Okay. Then the next is I, so that's your inside numbers. So these. And then your last. All right, do you see it? Yeah, first side, outside, inside, last. So when we do that, first is the purple, okay, r times r, which is r squared. And then next is outside, okay? So that is going to be r times 16. You see it? So we get 16r. And then next is your inside, which is again 16 times r. And then your last is going to be 16 times 16. So what's that? Now we'll bring all of this other stuff down, okay? Bring this stuff down. So it'll be r squared plus 576 equals all of this, okay? And you're just going to combine like terms and solve for r. Are you good? Okay, so try doing 22, all right? And if you don't get it or if you get stuck, let me know. I'm going to look at 24, okay? And then go on and help Lily with her questions. So for 24, that's a different theorem. And remember, we said that if we have two tangent lines that meet at a common external point, so in this case, point A, that those two segments are congruent. So you can set this one equal to that one and solve for x. And that's just algebra. So you should be able to handle that, okay? Now, Lily, you said what number? 4 and 12. Okay, Lily, so for number 4, what's your question? Yes, it would. Good job. And then for number 12, describe all of the common tangents of the two circles. Okay, so remember in class I said the first thing to do is to draw your tangent lines. Did you do that? Okay, so tangent lines, remember, are lines that touch a circle in one point. We're doing common tangent lines, so the same line has to touch each circle at only one point. And remember what we talked about, I said when you're doing common tangents, you need to look on top of the circles, on the bottom of the circles, and then in between the circles. So do you see where you would be able to draw 3 different tangent lines? So if you can see where to draw those, okay, here's one down here. Now what they want to know is that, well, they want you to describe it. And by describe it, they want you to actually write the equation of that line. So if you're looking at this, this is a graph, right, on a grid. What would be the equation of that horizontal line? Remember we said horizontal lines start with y equals, right? So what does y equal at every point on that line? Okay, well, here's your graph, right? And if this is 1 and this is 1, 1 over and 1 up, what is this line? This is at 0, right? So the equation of that tangent line would be y equals 0. Now you can draw another tangent line here. What would y equal at every point on that line? Okay, good job. Now the other tangent line, remember we said look on top, on bottom, and then in between the circles. So we had an example similar to this in the book. You can draw a tangent line right down the middle of the two circles like that. So this is a vertical line now, it's not a horizontal line. And when you have a straight up and down vertical line, it starts x equals. So what does x equal at every point on that line? It's not going to be that point where the circles meet. That's what they want on number 11. You're just going to tell me count over from here. So we're starting here, okay? And count over how many, what is that? So you go over 1, 2, 3, 4, 5. Yeah, does that make sense? Okay. Yes, Thatcher, that's correct. All right, Abby, so how are you doing? Did those make sense? Okay, did you look at 22? Okay. So Natalie, if you think you're wrong, take that number and plug it back in on both sides and see if both sides do equal each other. That's how you can check. Okay, so 33 says, on a softball field, home plate is 38 feet from the pitching circle. Home plate is about 45.3 feet from a point of tangency on the circle. So if you picture it, your home plate is here, right? So, and then here's home plate is here, and then here is your pitching circle. Okay, so they're going to throw the ball from here to home plate. How far is it from home plate to a point of tangency on the other side of the pitching circle? So we're going to go from home plate, which is here, to a point of tangency on the other side of the pitching circle, which would be here. Okay. So we have to say that this is a right angle, right? Because tangent lines meet at a 90-degree angle. So what it wants to know is the measure of this line. So what do you think that would be? Yep. And then for B, what's the radius of the pitching circle? So that you're going to work out just like those other problems, like these. You're welcome. Okay, Lily, so let's look at 28. 28 is going to be handled the same way as the problems that I worked from the book work. What we're going to do is we're looking at this triangle here, and we have to tell if AB is tangent to circle C, okay? So if B is your 90-degree angle, then we know that this side here is our hypotenuse, right? So if that's our hypotenuse, then what's the measure of that length? Okay, so 8 only covers this part of it. This part of it is R. So you see that it's R plus 8. Okay, so that's your C, okay? When you're doing A squared plus B squared equals C squared. R plus 8 is your C. Are you good with that? Okay. Okay, so then what are your A and B? Okay. And then what's b? Okay. So we would have 12 squared plus r squared equals r plus 8 squared. Are you good with that part? Okay. Let me make some room to work down here. Okay, so what's 12 squared? Okay, so that's going to be 144 plus r squared, because that just kind of stays the same, equals. Now, r plus 8 squared, do you know what that really means? How we would expand that? Yeah, you have to FOIL it. So we're going to have r plus 8 times r plus 8. Okay, so FOIL the first ones. What are our first two terms that we're going to multiply together? Okay, so what's r times r? All right, so that's going to be r squared. And then next in FOIL is our outside. So what are our outside terms? No, outside is going to be these two. The one on the very far left and the one on the very far right. So when you multiply those two together, what do you get? Okay. And then now what are your inside terms? Okay. And then finally, we do the last ones. So what are the last two? Okay, good job. Now, do you know how to solve it from there? Okay. And then 29 is going to be handled the same way. Okay. You just look at what your C is and plug into the same format we used for this one. Okay, so for 24, Lily, we have to just tell if segment AB is tangent to the circle, okay? And in order to know if a segment is tangent to a circle, it has to meet at a 90-degree angle at the point of tangency, which is that point where it touches the circle, okay? So if you look at 24, how do we know that that meets at a 90-degree angle? Okay, yeah. And then for 25 and 26, you're going to have to actually kind of work those out. Okay, don't forget to explain on 24. And then 25 and 26, when you work those out, that's how you're explaining. So, how would we prove if that's a right triangle or not on 25 and 26? But then how do we know that that angle equals 90? What formula have we been using? Yeah. So you're going to take those numbers that they give you on those two problems and plug into that and see if the two sides do equal. If they do, then that means those are right triangles. If they don't equal, then that means it's not a right triangle, so it's not tangent. Does that make sense? Okay, good. So Thatcher, take that and plug it into both sides and see if both sides equal each other.